now the game is getting even tougher with the last two sessions. The project of the year and the young tunneler of the year. So basically, the major project is the present project and the future tunneler that will be involved probably in the major project in next years. So for this first session, I come on the stage our first Vice President, Andrés Marulanda, that is going to chair this major project session. Thank you, Andrés.
Thank you. As we all know, complexities and challenges of major projects don't typically grow linearly as the project increases, but they become exponentially bigger. That is why the major project of the year category, projects above 500 million, it's the equivalent of the film of the year in the Oscars. So I would like to invite our 4 finalists to the stage. First of all, we have the Grand Central Madison project in New York, and I would like to invite Mike Pujak and Nasri Munfa to the stage, please. Next, Mr. Henri Bernard and Massimo Marotta from Singapore Thompson East Coast Line, contracts 222 to T310. Next, we have Mr. Sang Tseng and Mr. Wang Bingbing from the single board double deck municipal tunnel with super large diameter. And finally, Mr. John Sage and Brooke Knight for the Thames Tideway Tunnel, London's new super sewer. Thank you. Thank you. So we will start introducing ourselves. Nasri and Mr. Pujak, do you want to introduce yourselves? You have a mic?
Yeah, maybe. Hello, everybody. My name is Mike Pujak, and I am Vice President and Project Executive from AECOM. And I spent over 2 decades on the Grand Central Madison project. Project Executive for the last 4 years for the PMC that AECOM led.
Good afternoon, everyone. I'm Nasri Munfa. I'm principal of Gal Zeidler, and I have been in this business for over 40 years. And I was the first chief engineer of the project that you're going to hear a little bit about it now.
My name is Massimo. I'm from the Singapore Land Transport Authority. I'm very happy to be here also because, for those who didn't guess by the name, I'm Italian, so I'm at home. And I'm very happy also to represent our team for this project, the Thompson East Coast Line MRT, which we recently opened to public.
Yeah, good afternoon, everyone. I'm Henry Bernard, representing the client side, Singapore Land Transport Authority. I'm the project manager overseeing this Thompson East Coast Line.
Good afternoon, everyone. I'm Zhang Zheng, the Deputy Project Manager, and also I got my colleagues who is sitting down there, is our Chief Engineer.
Hi, good afternoon, everyone. I'm Brooke. I work for Jacobs, who are the Programme Manager on Thames Tideway. The programme's split into 3 sections, and I'm a Senior Project Manager on the eastern section of the tunnel.
Thanks, Brooke. Good afternoon, everybody. I'm John Sage, delighted to be here. I'm the Head of Corporate Responsibility for the Tideway project. I'm responsible for Tideway's long-term delivery of benefits to London.
Thank you. So we have 4 outstanding projects, so let's start with it. So we will start with the Long Island Railroad access to Grand Central Madison. By the way, EXCO was able to visit this project a couple of years ago, and it was an extraordinary experience to visit it and experience it firsthand. So please, who's going to present my video?
Good morning. I'm Judith Kunoff, the MTA C&D Program Executive of the Grand Central Madison Construction Program. I'm joined this morning by Michael Pujak, Program Executive from AECOM, Nasri Munfa, a tunneling engineering expert from Gal Zeidler, to share with you this great project, worthy of the ITA's annual major project of 2024. Grand Central Madison was the MTA's largest ever tunneling project and largest ever construction project in the MTA's history. Additionally, it serves as the first expansion in more than 67 years of the Long Island Railroad, the largest commuter rail service in the United States, serving more than 75 million riders annually. Grand Central Madison is a new direct rail line extending from the more suburban county of Queens to the historic Grand Central Terminal, located on the east side of Manhattan, under one, if not the most congested and busiest urban center in the world. The project opened to the public on January 25th, 2023. Grand Central Madison is truly a mega project. With over 8 miles of new tunnels excavated between Manhattan and Queens and over 1 million cubic yards of concrete poured, the configuration is a significant complex tunneling system. The project incorporates the lower level of the 63rd Street Tunnel that was constructed in the 1970s and reserved for a future Long Island Railroad expansion. In Queens, we constructed a network of new tunnels under the busiest operating interlocking in North America, while in Manhattan, we built another series of tunnels as well as a new terminus connecting to the historic Grand Central Terminal and the second largest commuter rail, Metro North Railroad, and the extensive New York City subway system. A project of this magnitude can only be successfully completed with a great team. The project owner is the MTA, with AECOM serving as the program management consultant and Gal Zeidler's consultants as the leading tunneling expert specialists. The major benefits of this program include reduced commuting time to Manhattan's east side, support reverse commuting to Long Island, increase Long Island Railroad train service, and most importantly, improve regional resiliency by creating a redundant route to and from Manhattan and Long Island. Mike Pujak will now drill down into more detail, beginning with the Queens tunneling. Mike?
Thank you, Judy. We're now going to look at the Queens segment of the project, where we built 2 cut-and-cover sections of tunnel, 4 new TBM tunnels, and a tunnel segment below Northern Boulevard. One major challenge that needed to be overcome was working around the active railroad in Harold Interlocking while maintaining the current level of service. Harold Interlocking is the busiest interlocking in North America, serving 4 railroads and over 740 trains per day. It required a complete reconfiguration in stages to maintain rail operations through construction and to accommodate the new service. Prior to the TBM tunneling, a significant geotechnical boring program was completed to better understand the geology in this area. Given that the geology was soft ground comprising of sand, gravel, clay, and boulders, with a high groundwater table and the presence of contaminants, the project utilized 2 7-meter diameter slurry TBMs for the mining. Concurrently with the mining, the TBMs erected gasketed precast segments to complete the structure. Between the 2 cut-and-cover segments of tunnel lies Northern Boulevard, which is a main artery in Queens for vehicular traffic. Additionally, at this location, there are subway lines above and below Northern Boulevard. Given these characteristics, a mandate not to impact train operations or the roadway, and the geology in this area, which was similar soft ground with boulders and high groundwater table, the team used sequential excavation method of tunneling here. While working from the adjacent access shafts, the team installed an array of horizontal ground freeze pipes and froze the ground for an initial groundwater cutoff and temporary ground support. Additionally, pipe pile supports were installed and a load transfer was completed to address the overhead subway structure loads during the excavation. Next, the contractor completed the excavation in 3 headings and 9 excavation drifts. A robust structural and geotechnical instrumentation program was utilized to complete this section of tunnel successfully. In Manhattan, at nearly 50 meters below the street in virgin bedrock consisting of high-strength and abrasive Manhattan schist, several underground excavations were completed for the new train service. Coming out of the existing 63rd Street Tunnel, a new network of tunnels for a total length of 9.7 kilometers were excavated using 2 7-meter diameter gripper TBMs. The two tunnels bifurcated twice, allowing 8 trains to enter the new station caverns. In addition to the TBM tunnel excavation in Manhattan, over 3,500 blasts and the use of road headers for mechanical excavation were needed to create a series of caverns along the tunnel alignment. One of the biggest challenges for the excavation was that there were no receiving pits for the TBMs, and therefore each of the 2 TBMs in Manhattan needed to be backed up several times to complete 4 drives each. The twin station caverns are each approximately 18 meters wide, 20 meters high, 348 meters long. Each cavern allows for up to 4 trains to platform on the upper and lower levels. Following the completion of the top-heading excavation, the concrete structural arch was cast in place into a rock haunch to mitigate the risk of ground movement prior to continuing the excavation. In conjunction with the construction of these 2 massive station caverns at a depth of over 10 stories below ground, the project needed to excavate several vertical and inclined shafts. These shafts are used to connect the caverns to the new passenger concourse built at the lower level of Grand Central Terminal. The excavation of the Grand Central Caverns was one of the most challenging elements of the project because of the limited access from Manhattan. With these caverns being excavated over 50 meters below historic Grand Central Terminal, which is over 100 years old, significant coordination and extensive planning was required to ensure our success were not impacting railroad operations or the structures above. Now I will turn it over to Nasri.
Thank you, Mike. I will now present how this project meet the ITA awards criteria. In the next few slides, I will present some of the most innovative solutions and sustainability aspects implemented on the project. We implemented several innovative solutions in the Manhattan segment. For example, the geometrical configuration of the tunnel that split from 2 tracks to 4 tracks and then to 8 tracks, all under highly developed area in the heart of Manhattan, was critical to achieve the level of service needed. Along with that, we eliminated the TBM launch and retrieval shaft in Manhattan. All work was done from Queens, and all muck went back to Queens, eliminating thousands of trucks from Manhattan streets. To excavate the crossover wires, we ran the TBMs through them, then placed soft concrete in part of them and did another TBM run, thus minimizing the drill and blast work. We used precast concrete element for the station interior structure, reducing the underground construction, and we eliminated thousands of concrete trucks from the street. In addition, we provided 17 high-speed escalators, reducing travel time in and out of the station and enhancing passengers' experience. In Queens, several innovative solutions were implemented. We used horizontal ground freezing to stabilize the large soft ground SEM tunnel under Northern Boulevard and New York City subway lines. The design criteria limited the settlement to 12 millimeters, which was achieved with precise sequencing of the excavation, the immediate installation of the initial support, and maintaining phase stability at all times. The work was completed with no interruption to the street traffic or to the subway operation. In general, the project provided numerous sustainability aspects, including the station's long service life. It reduced congestion, increased capacity, and reduced commuting time. The project created thousands of jobs during construction. It was a source for mentoring and training young professionals and workers, and it provided hundreds of permanent jobs. It improved the regional connectivity in the greater New York area and helped maintain its status as the global economic hub of the world. However, not all innovations are related to underground construction. The artwork in the station left a lasting impression with the public. Several art pieces from local and world-renowned artists were integrated in the station. With the addition of large underground retail spaces, the station became a destination rather than simply a transportation facility. Now, I'll turn the presentation over to Judith to close.
Thanks, Nasri. This slide shows the New York State Governor's thoughts on opening day. However, as Governor Hochul said as she disembarked from her inaugural train run, Grand Central Madison is a game changer for New Yorkers, and I look forward to welcoming Long Island commuters to this tremendous new terminal. Infrastructure is all about connections, and this project is an extraordinary step forward to better connect millions of New Yorkers with their homes, their families, and their jobs. In closing, Grand Central Madison typifies all ITA criteria, as it is one of the most complex and challenging projects completed in the heart of Manhattan. Realizing the original vision, decades in the making, Grand Central Madison is a regionally transformational transit terminal. offering a one-seat ride to and from Manhattan's East Side, shorter commute times, and enhanced economic development opportunities. This new terminal and its expanded transit service is truly a game changer. Thank you.
Outstanding project. Congratulations. So we move forward with the Singapore-Thompson East Coast line.
All right. Good afternoon, everyone. So I will bring you through the Thompson East Coast Line project. All right. Greetings from Singapore, a city-state with 4 official languages. We are the tunnel team under the Land Transport Authority, an agency under the Ministry of Transport, responsible for planning and development of the Singapore transport system. We bring together various ethnicities and we represent the Singapore racial harmony and we work as one team. So Singapore, spanning just 728 kilometers square, we offer an MRT network of over 200 kilometers and we're not stopping there. Here, construction is still ongoing for new lines and more to come. And Thompson East Coast Line, or in short, TEL, a 43-kilometer underground, managed by 6 civil teams. And for today in presentations, I will cover for the sections that is covered under managed by civil team 4 and 5. And with the recent opening in June this year, this entire section has been fully operational. So the TEL, it benefits the residents and also the tourists as it connects from the CBD area to the iconic gardens by the bay. So you can visit when you come to Singapore. And also it provides a future connectivity to the Changi Airport Terminal 5, slated to be open in 2035. Yes, Singapore is very small, but we have a complex geological formations. From the north to the central, we have Bukit Timah granite and igneous rock formations and highly abrasive due to this high quartz content. In the east, old alluvium basically is the sediments brought down by the closely connected rivers. In the west, basically is a sedimentary rocks. And lastly, at the CBD area, slightly to the east, we have Kalang formations where it is a buried marine clay and a river deposit. Not to forget all the contributions from the consultants and the contractors for the success of these projects. All right, due to limited time, I'll be focusing on the projects that is highlighted in yellow, mainly the challenges and the solutions that is relevant to our tunneling in urban area and also complex ground condition. We know that as we build more MRT network, inevitably more and more comments of the complex interfaces will come, such as, for example, with parallel undercrossings, live tunnels with only 1.8 meter clearance. Another contract also, we have to underpin or even undercross 2 live tunnels using a mine tunnel. So let's see, one of the most challenging contracts, we construct 2 stacked mine tunnels and a pedestrian linkway above it, which is right beneath 2 live MRT stacked tunnels. Well, we just like to stack it up. But well, they are formed in a soft clay and fluvial soil. So the settlement control here is critical. So the innovative solutions that we adopt here is we leverage on this future pedestrian linkway during the constructions, where it allows us as the access to remove the piles of the existing tunnels. And then it's also create the access for us to construct the ground freezings to facilitate the mine tunneling works. So the 2 sections of the linkways, it is constructed using the open face rectangular TBM, which is then we are able to underpin the tunnel above us. And also we install the row of pipes that is in order to form a ground freezing curtains to cut off the groundwater. All right, now we move on to another contract. Similarly, we have tunneling under live tunnels, and it is also found in the soft grounds. So, in order to protect these tunnels, we basically install a canopy of 0.8 meter diameters of pipe roofing using a micro tunnelings. Here, we also stack the tunnels under the roads as we have to avoid the cluster of buildings. So, we have a space constraint here. All right, not only under crossings, in these contracts, we actually built our tunnel above the road tunnels with a clearance of only 0.3 meter clearance. We studied various alternative options alignment. Nevertheless, it causes more disruptions or even risk to the communities. So when we speak about the space constraint, this constraint smack right in the densely populated area where we have difficulty in even planning our launch shaft. So we took up the challenge by launching it from the adjacent station's launch shaft. We bore through the stations and we dock in at the adjacent stations. Yes, we know that in the urban tunneling, sometimes space constraint may not be only problems. We also know that the disturbance to the public is always a concern. So in this contract, we implemented a mud pumping system into our TPB machines. So, this solution actually gives us, we are able to reduce the size of the shaft due to the implementation of the mudscape, traditional mudscape, but we also eliminate the noise pollution from the generated by the tipping of the mudscapes. Hence, it minimizes the disturbance to the publics. This solution actually tells us or demonstrates how we as an engineer, we can balance the development needs and the residents' quality of life. And lastly, in this contract, D228, we're tunneling under the Marina Channel, a freshwater reservoir in Singapore. One of the key features in this project is that we tunnel the two drive using only a single TBM. So we engineer a solution for using a turntable at the retrieval shaft. So we allow the TBM to execute a U-turn, which is then able to give us a productivity of reductions of the construction time by at least 2 months. Yeah, so from the undercrossings of the live tunnel to overcrossings the road tunnels, from a space constraint to the complex ground conditions, we have successfully completed the tunneling for the Thomson East Coast Line. And I would like to express my thank you to all the parties involved, consultant, contractors, TBM supplier, material suppliers, and of course, my colleagues from the LTA tunnel team, and of course, all the audience that presents here. Thank you so much.
Thank you. Another extraordinary project. So we move forward with our next finalist, and it's the single board double deck municipal tunnel with super large diameter from China.
Though it is extremely challenging to construct a super tunnel in the center of Shenzhen, with a diameter of 15.8 meters super large diameter shield, our team have been working together to accomplish this feat. And now I would like to introduce our team and this major project, Chunfeng Tunnel. The client for this project is Shenzhen Transportation and Public Facility Construction Center, and the contractor said are forming a three-dimensional transportation corridor of Chunfeng Road Viaduct and Chunfeng Tunnel, which will effectively reduce traffic congestions, promote the integration of Shenzhen and Hong Kong, and improve people's travel and urban environment. The project is an EPC project, is 1% invested by the government, and the total contract value is 580 million euros, and the total length of the project is 5,078 meters, and including 3.6 kilometers of the shield tunnel. The total earthwork of this project is 1.16 million cubic meters, and also the concrete in this project casted is 270,000 cubic meters. There are three major challenges in this project. This large shield and large barrier depths is typical long distance, softness, hardness, unevenness, flexible, and high viscosity strata, and it's risky. It's causing 28 buildings and structure from the buildings and 78 buildings and structure from the side. Overcoming the impact of the small set through procedure simulation, module assembling, and other measures, our team took 38 days to complete the shield assembling and launching. The project involving many pipelines and various kinds of building structures at the receiving end makes the receiving very risky, and our team used the short steel sleeve receiving for the first time in China, which is 2.5 meters long. Our team used the powerful intelligent big data platform for shield TBM to realize the intelligent tunneling of the shield. With the surveillance cameras and AI intelligence to capture and warn people's unsafe behaviors and unsafe condition of objects. The whole construction cycle went through 2,640 days of zero accident and zero casualties. Our team used Vim and GIS and other technologies to build a safe risk management and control platform to monitor and evaluate construction parameters and monitoring results, risk results, and other construction parameters in real time. Our team used automatic monitoring and awareness transmission of data for real-time viewing of building structures to provide data reference for dynamic adjustment of construction parameters and measures. Our team established a structural analysis model to analyze the impact of the shield and passing on the ground and houses to provide a reference for the production of building structures and the settling of monitoring and early warning values. Our team used Vim to carry out component inspection, visualization technology disclosure, progress management, and quality management. Our group also pioneered the front-mounted cut barrier, and which increased tool carrying capacity by 30% and reduced abnormal tool damage by 83%, and innovated tool wearing detection means with accuracy of wear detection reaching more than 95%. The shield shell mud injection can achieve precisely control of sedimentation, ensure simultaneous grouting fullness, control of segment floating. The high-definition visual system achieves the view of the tunnel face without opening the partition by lowering the liquid level. About 210,000 cubic meters of shield mark was processed to realize resource utilization, of which fine sand can be used as raw materials for simultaneous grouting, with a dosage of about 62,000 cubic meters. The prefabrication and assembly rate of the tunnel reached 78%, and the execution and assembling construction was synchronized, saving the construction schedule about half a year. The tunnel was built into a single-hull double-deck structure, realizing two-way traffic flow and increasing the utilization rate of the tunnel space by 50%. The hanging pipeline design made the tunnel clean and beautiful, and the centralized arrangement facilitates inspection and maintenance during operation, reducing working stress by 20%. The air purification system inside the tunnel effectively removed particles and harmful gases, improved the urban environment. Adhering to the concept of smart city, the ground facilities were renovated, and 30,000 square meters of public spaces were released after the reconstruction to provide citizens with leisure places. The tunnel entrance and exit are fully covered by the sound barriers to observe and reduce the spread of the noise, and this roof adopted a parametric design to form a natural transition of view and lights. Our team provided faster and more efficient traveling options, shortening the passage time by traveling about 20 minutes. The project has been awarded with many certificate and letters of commendation by the clients and industry authorities for many times with good evaluation for all parties. The project has obtained a series of innovation patents. Through the innovation of technology and the practical application effect is really good. I would like to appreciate the team and all participants for their dedication, support, and encouragement. The Chunfeng Tunnel is a high-profile super project changing the status quo and creating the future. That's the end of this presentation. Thank you so much.
Congratulations. This year, we were able to visit Shenzhen for the WTC, and we saw how this type of infrastructure projects have transformed the city from a small village 50 years ago to a mega metropolis, both above ground and underground. Okay, we move to our final project, the Thames Tideway Tunnel.
Thanks. Good afternoon, everyone. As you know, I'm here to talk to you about the Thames Tideway Tunnel, which is a super sewer in London. So The super sewer is the UK's single greatest intervention to tackle sewage pollution in the UK. And it's the biggest in London since Bazalgette's original system was built in Victorian London. How has this been done? So we've done this by driving a 25-kilometre long tunnel connecting 24 sites, which all sit above ground in densely populated urban environments. And we've done this using 6 TBMs through London's different ground conditions. At each of these sites, we capture flow which would otherwise go into the River Thames, as well as capturing 30 million tonnes on an average year. Tideway set out with the ambition to reconnect London with the River Thames. Tideway was set up as a licensed water company to deliver and operate the new system. This is a new model for UK infrastructure. The delivery of the programme has been supported by alliance partners, Jacobs as the programme manager, and 3 joint ventures made up of 8 major construction companies from across Europe. Commissioning began in May this year, and on just one day in September, we were able to capture 700,000 metres cubed on a wet day before the project has been finished and with only a few small sites connected and live. How have we innovated through collaboration? Safety is of paramount importance to everybody on the project. Right Way in delivery is the client-led approach, which has ensured a common approach and consideration of its importance across the Alliance. For absolutely everyone who works on the programme, this starts with EPIC. EPIC is a one-day immersive induction which the client continues to invest in to develop the right culture. To date, we've undertaken 40 million hours of working time without any life-changing injuries. Other projects in the UK have adopted the induction, and I think this is testament to how effective it has been. People leave the project reflecting on the culture there and take those lessons to their next projects. How have we used digital tools? Digital tools have been used across the programme at different scales, from, of course, having an overarching BIM model to using them to communicate and plan at not just site, but also task level. We engage through this the whole workforce in the planning of works, and it improves our ability to deliver them safely. We also use site-wide planning tools to, on-site, improve efficiency and minimise the impact to our many neighbours. One of the key sites where we did this was where I was working in South London. Following a series of unexpected events, we ended up with a underground structure full of water in one of the only landlocked tideway sites in London. But we were able, through careful planning, to undertake a huge ground remediation programme without impacting the overall programme and readiness for system commissioning. Tideway has invested, through its innovation programme, into developing a precast secondary lining machine with a full-scale prototype being manufactured to test its effectiveness and efficiency. Because of the funding, at the same time, the joint ventures were able, through the Alliance, to develop improved concrete mixes, which enabled them to reduce the thickness of the secondary lining. Overall, this is the approach that was used, and the thickness in the secondary lining saved over 5,000 tonnes of carbon dioxide and equivalent emissions. And finally, for me, onto inclusivity. Overall, the collaborative approach has made the project one where people want to work and want to stay, because they can really make a difference. Not by design, one of our construction sites, I'm sure you'll agree unusually, had a fully female leadership team. Tideway welcomes all diverse perspectives from all levels of the workforce through collaboration, and it's inherent in the culture that everybody has a voice. All day, every day, but also back to Right Way in delivery by awarding monthly knowledge sharing against our 6 Right Way pillars and celebrating success at annual awards.
Thank you, Brooke. So I'm just going to talk to you about Tideway's long-term benefits and how we're delivering a sustainable legacy, not just by cleaning up the River Thames in London, but by how we're delivering the project. And we started, understandably, I guess, looking at the river itself. What an amazing opportunity we had, tunnelling underneath the River Thames, pretty much following its path from West London to East London. And we designed right at the start to use the river as much as we could, taking more than 90% of the material that we took out of the ground away by river, having a significant amount of our materials coming in by river, including a couple of TBMs, and that's quite the sight in central London as a TBM comes down the River Thames. Overall, we saved nearly 350,000 HGV journeys and almost 25,000 tonnes of CO2e by that approach. And the material that you can see being taken out there by, in the top left picture, by barge allowed us to build new wetlands in the estuary to the east of London, which are already attracting new species of birds, so that's great to see. Also want to mention river skills. It was a really great opportunity, not just to create jobs, but to change the game in terms of the skills associated with the River Thames. We were the co-founders of an organisation called the Thames Skills Academy, and I'm really pleased to say that we're completing our project, but that Academy now has 70% of Thames operators as members, which is a great legacy for us. Just want to talk a bit about our above-ground legacy, as well as obviously the incredibly complex tunnelling. We're creating, as part of the completion of the project, 7 new riverside spaces for the River Thames, the first major changes like this to London's embankment since the Victorian times. So if you're in London, go and have a look at them, because they really are a great way of how, as we put it, reconnecting London and visitors to London with the river. As well as that, we've tried to make a virtue of the above-ground assets that we're leaving behind. More than 800 square metres of our kiosk roofs, where we have the instrumentation to run the tunnel, have got biodiverse roofs on them to support biodiversity and also some additional climate resilience. And that picture bottom left there, we think that's London's largest bug hotel. It's actually the back of one of our kiosks to encourage more biodiversity. Just want to talk about people legacy, because this is about how we think we've changed the game while we've been working on the project, and it combines innovation and community and sustainability. So the picture top right is Lena Begum. She worked on the project in the west of London, and she applied to our innovation fund, which we set up with our main works contractors to allow them to bid for a pot of money put up by the client team to improve either the project's carbon footprint or its diversity or any other aspect that they thought they wanted to apply for. Lena won some of that money to create, for the first time in UK construction, PPE for those who observe the hijab. And as well as a great innovation, she actually created quite a nice business off the back of it, which was great to see. And finally, I just want to mention how we've innovated around the sustainability of the project through financing. So legacy delivery is actually linked to the project's financing. And if we keep all our commitments, and we set 54 commitments at the start of the project, on track against what we said we were going to do in any given year, we get reduced interest on the debt for the money that we borrow to deliver the project. And believe me, when you're in project meetings and the finance guys are interested in some of this soft stuff, then it really does begin to see the game changing. So I just want to summarise on behalf of Brooke and I some of the outcomes that we've seen from the Tideway project. As Brooke said, after 10 years and 40 million working hours, we've had no level 1 injuries, and we're incredibly proud of that. But wider than that, we set a transformational approach which focused on things like mental health. Construction, as probably can be seen in many, many projects, is one of the worst sectors for problems with mental health. And we were one of the co-founders of a new charity designed to tackle this issue and, as the charity puts it, to start the conversation, to get people talking. The environmental benefit Brooke has already mentioned. It's great to see we've started to clean up the river, and the fact that while we're doing it, we've got a 28% carbon reduction against the original estimate. And obviously on the key test, time, cost, quality, very pleased to say that the schedule is within the regulatory timeline. The cost is within the original bill impact on the water bill players of London. And in terms of the quality, the client reference design has had only 5 significant changes in 10 years, which is pretty remarkable. And I've already covered this point about legacy, which is not just what we're leaving behind in terms of a cleaner river, but the things we're doing on top of that, not just above ground, but also in how we've created a culture within the organisation to encourage innovation. On behalf of Brooke and I, thanks very much for listening.
Thank you. Another outstanding project. Throughout the day, we have heard the comment that the jury had a difficult time making a selection. Well, certainly this category is no exception. So now we have some time for the panel discussion, and we will again start with the Long Island Railroad to Madison project. The video highlighted the complexity of the congested area and the density of the urban intervention. Could you highlight some of the innovative approaches that you devised to minimize the impact on residents, businesses, and communities in the area?
Thanks, Andrea. One of the early decisions that we made on the project is to eliminate the launch shaft and the retrieval shaft from Manhattan and have all the material and all the excavated material moved back to Queens, where the existing railroad yards. As a result of that, we kept business on the surface as usual. We established an assembly cavern for assembling the TPM. The TPM came in components and were assembled in the cavern, and then they launched from there. Another major element is to divert from 2 tracks to 4 tracks, all within a confined space, and then divert the outer tracks going underneath the inner tracks, and then end up with 2/2, and then split again, so we'll end up with 4/4 going into the caverns for the station to provide 8 platform edges. So that was all done under Park Avenue with very little impact to the surface. Most people did not even know that there are construction activities going on underneath.
Yeah, and just to add to that, in Queens, we had a segment there that we had 2 cut and cover tunnels that we had adjacent to one another. But just between them, we had a major artery or a highway there that led to one of the major bridge crossings to Manhattan. So we had a stipulation where we couldn't close that road, as well as we had 6 subway lines between the elevated subway line and a below-grade subway line. So we did a ground freeze there between the 2 shafts and a sequential excavation for that 120-foot segment of tunnel. But that allowed us to not have any impact to both the DOT and the vehicular traffic, as well as the subway that runs 24/7 in New York.
Thank you. Well, this project resulted in many outstanding achievements, but what are you guys personally proud of the most about this project?
Well, I think in terms of this project, I mean, the lasting impact that it's going to have is that it provides a redundant route for the Long Island Railroad to Manhattan. You know, this is something that we saw with climate change and some of the damage that had been done, some of the big storms that we've had in New York. About a dozen years ago, we had a big storm that wiped out the current tunnels, the East River tunnels, which is the major artery for both Amtrak and the Long Island Railroad commuter train. So it had wiped it out, and there's significant damage that was done to that 100-year-old structure. This allows for the region now to have additional connectivity and know that we're sustainable from that element and be able to sustain big storms going forward.
One of the things that remarkable for me, when we started that a long time ago, I realized, or we realized as a team, that we really need to bring the technology, the latest technology to the US to build a facility of that nature. So we reach out to the various parts of the world, and we got a lot of lessons learned from other places. But the things that unique is I see people right now, neighbors and friends, and they ask me, have you seen this facility lately? And I say, yeah. see the artwork that was integrated in the project, and say absolutely, and that what is a lasting impression, that the integrated artwork in the terminal itself. The terminal became a destination. There was an article in the paper said that we come to the station from Long Island to shop and spend the time there and go back without even getting out to the street.
Great, thank you. So we move to the Singapore Thompson East Coast project. We saw that the project involved multiple engineering and contractor teams. This generates, of course, a lot of challenges for interfaces. Could you elaborate on some of the techniques and strategies that you devised to minimize the interference risk and promote better coordination and achieve consistency in terms of cost, health, and achieving the program schedule?
All right, yeah, thanks. I try to keep it simple, my answer. So as a client, we are the core, so we are the centralized project management, and we regularize down from the QA, QC into the safety aspects, but we take into the two-way communications, basically, on any initiative or even innovative idea from the consultant and the contractors. So that is where we have a daily interactions with the consultant and contractors, or even involving stakeholders within that area, or even the publics that is required to meet the needs. And that is how we actually, the daily routines that we have. And in terms of the timeline itself, we actually set up a baseline together with the contractors down to even the tunneling rate sometimes, in order to see how we are able to optimize our projects. Yeah.
Thank you. In your presentation, we saw that you contemplated very diverse and varied tunneling methods, ranging from ground freezing to shield tunneling to conventional tunneling. Could you tell us a bit more of why you ended up deploying such a diverse set of alternatives, and what type of risk did you identify to make that decision?
Yeah, so I would say that all of the tunneling in Singapore is urban tunneling, and very often we interface with the infrastructure, with the road. In this case, with the live MRT, we need to undercross two live MRT, and we want to keep them live as much as possible, right, during the construction stage. So in this project, actually, we didn't use innovative solution taken individually. We use ground freezing, we use horizontal jet grouting, we use the rectangular TBM. But I think the innovation is to be able to package and utilize existing technology in a way that we can solve challenges. I mean, we don't need to always reinvent the wheel, but sometimes to find a solution, holistic solution with the existing technology can help to solve the challenges. In this case, we need to underpin the existing tunnel, to remove the existing pile. We need to build a permanent linkway, and we need to excavate the stack tunnel. So we decided to use this permanent linkway as an access during the construction stage to be able to execute the ground freezing, this one to facilitate the mine tunnel excavation. So with this kind of solution, we were able to complete successfully.
Thank you. So we move to Mr. Tang. In your video, we saw that you also intervene in a very dense populated area. So what type of techniques did you use to minimize the impact on surrounding infrastructure and buildings? Could you elaborate on this, please?
Okay. Actually, it's this TBM is crossing Bennett's 28 buildings, and also by the side it's crossing 78 buildings. So in the beginning, we did very detailed, comprehensive investigation for all the buildings to see what is the foundation for the building, whether it's with piles or with shallow concrete foundations. And we also did some structural analysis to see when we are crossing under it, how the building will behave, to give us some reference to adjust the parameters when we are driving TBM under it. And the second one is that we also did some investigation for geology. We drew many holes in there along the line, and to see what exactly it is inside the ground. And for some of the parts, actually, we found if there's a voice in the ground, we are trying to inject. It's kind of a pre-enhancement for the ground, so that when we are driving TVM under it, the ground will not just settle so sincerely. I think the third one is that for the we have calculated before we're driving TVM. We have calculated theoretically what the parameter for driving TVM, and also in the beginning of the project, we have did a trial section to see if what we have calculated is similar to the reality, to see to adjust these parameters for the TVM driving.
Thank you. At the end of your video, you shared with us some testimonials that summarize some of the achievements of the project. If you were to give us your personal testimony about the main achievement, in your opinion, about the project, what would it be?
I mean, okay. Actually, I think this project is really meaningful because it's right now it's in the real middle of Shenzhen city, and also it's very close to the border between Shenzhen and Hong Kong. It will give the people a third option for like the traveling from one crowded areas to the other areas, and and also this kind of project is actually it makes this city more complete. You know, before Shenzhen is really a small village, and about 40 years ago, and by a lot of projects like this, we are making this city a more convenient city for all citizens. And I think that is what we feel proud of.
Thank you. Now it's the turn for the famous Tideway Tunnel. If you were to highlight the main issues that you think helped the Thames project to move the way we deliver this type of major infrastructure projects, what would they be?
Thank you, Andres. I think I would pick three things as to how the Thames Tideway project has raised the bar, if you like, for the delivery of infrastructure through tunnelling. The first, to come back to the point Brooke made, is we all try to keep people safe. We set the bar for our health, safety and well-being to be transformational, and as a consequence, we had to spend a big investment in the EPIC induction program that Brooke mentioned. But after 20,000 people have been through that, and nobody works on the project without going through it, however long or short they're on the program, whichever job they have. And to see other projects, now other UK projects picking that up, says this was the right approach, and that investing in that immersive experience, including actors, was the right thing to do. Second thing I'd say is how we've looked at the delivery of long-term legacy at the start of the project. So building in the opportunities for the Thames and London, as well as building this asset. And I loved hearing the guys from New York talk about the public art. I didn't mention it, but we had 50 art commissions as part of these new riverside spaces, and exactly the same thing is true. The public absolutely loved it, because we made a virtue of some of the engineering, like the vent columns, where we have to air manage the system. We put poems up the side of the vent columns, and when you read each of the vent columns on each of the riverside spaces, it makes a total poem, reason to go and see the next one. So that long-term thinking at the beginning of a project is really important. And probably the third thing, to come back to the other thing Brooke said, was culture. I think, as we finish the project, we're hearing from people moving on to other projects saying, yeah, but it's not like it was on Tideway. And I think that's testament to how you build a working culture that encourages people to bring their whole self to work, to feel as if they're going to be treated fairly, and if they've got ideas, to have the opportunity to put them forward.
Thank you. And our final question, it's in the same sense as what I've asked the other finalists. If you were to select the greatest Tideway's achievement, what would it be?
I would say the greatest Tideway achievement is the approach where everyone has a voice and that voice is valuable. Anybody can have a chat with the Tideway CEO. In fact, he regularly has cigarettes with people in the workforce, and he takes on board those ideas that are shared with him. Equally, my program manager is very open. From when I first started on the project within the engineering team, I had the opportunity to talk to absolutely everyone, and just feeling that your voice is valued really sort of accelerates everyone on the program to be their best selves, and I think that's what's great. Everyone's left really feeling their best.
Thank you. So congratulations to you all. It's a great achievement just to be here. So we're ready for our next category. Andrea, you want to introduce it?